The overall conviction among most specialists is that the hypothesis of how things came to be stays the major explanation for the early seasons of the universe. This speculation joins the improvement of stars, planets, and, in this way forward, life on those planets, counting ourselves. Despite its odd name, the huge explosion, it offers an enlightening appraisal concerning what might have happened at first. The universe was thick in a short space, more thick than a pinhead with particles thickly pressed. From this second, a beast impact of matter and energy happened, known as the enormous detonation. This event, happening billions of years ago, set up the spreading out of cosmic history. In any event, insensible data, it has set off making peculiarities with the suspicions of this speculation. Right when NASA sent off the James Webb Space Telescope, the largest and most advanced space science observatory ever, specialists surveyed that its understanding would confirm the speculation of the universe's beginning stage. Tragically, after just a single year in space, the telescope paralyzed specialists with its capacity to peer so deeply into the universe's past. The James Webb Telescope's amazing capacities have uncovered countless universes going as far back to a time so old that it challenges how we could interpret the universe's starting points. This exposure has begun a serious assessment concerning what existed before the Big Bang. One significant moment in this mission happened when cosmologist Rohan Natu, working with data from the telescope, suddenly tracked down a system from just a short time after the Big Bang, making it the most far-off universe ever seen. Natu's revelation sent shock waves through established specialists, highlighting the astonishing abilities of the James Webb Telescope. Its immense potential to truly impact our viewpoint on the universe has scarcely begun, promising to uncover astonishing insights into the earliest times of the universe's existence. This period, hardly engaged on beforehand, holds the key to understanding the development of the first stars and galaxies. The telescope's discoveries have conflicted with head speculations, uncovering systems with traits that outmaneuver past assumptions. This excellent surge of early universes has ignited a storm of scientific inquiry, testing specialists to adapt these discoveries to existing hypotheses. As investigators uncover these openings, they face key inquiries about the very nature of the universe and the forces that shaped its development. Beyond the James Webb Telescope's benefits, which are clear, it is seen as 1.5 million kilometers away from Earth, protected from limitless interference, and cooled to approach absolute zero by its tennis court-sized sun shield. The telescope combines an enormous primary mirror and incredibly delicate instruments designed to uncover details of the early universe that were previously confidential. This period, known as the Vast Dawn, happened around 200 to 300 million years after the Big Bang, marking the event at which the first stars and galaxies began to form. The process by which this unfolded remains a subject of intense inquiry, with theories ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's view of galaxies from the Big Dawn presents a unique opportunity for cosmologists to test how they may interpret these complicated elements. By studying these ancient systems, experts can either confirm the validity of their current models or reveal gaps in understanding that could lead to major new revelations. The telescope was expected to observe a few weak and small galaxies in its pilot studies. However, the truth has far surpassed these expectations. The telescope's early images of the distant universe revealed a wealth of galaxies with ages, sizes, and luminosities that challenged all forecasts. This stunning flood of early galaxies has sparked a race among space specialists to establish new benchmark records for the earliest known massive systems, with new discoveries arising continuously, leaving traditional experts in awe. Following the James Webb Telescope's revelations, informed authorities and onlookers have rushed to study the existence of these remarkably advanced early galaxies. Some speculated that errors in the telescope's understanding of large observations could be responsible for these startling discoveries. That said, the consensus remains that these discoveries represent a paradigm shift in how we might interpret the early universe and offer exciting glimpses into the potential for immense progression. The new revelations from the James Webb Space Telescope about galaxies have raised huge questions regarding the nature of the universe and tested the assumptions of standard cosmological models. While some experts are investigating whether these insights can be reconciled with existing theories, others suggest that they might be the first signs that the universe is far more complex and puzzling than previously imagined. The crucial question at play is our basic understanding of how the universe we know arose out of primordial chaos. The early discoveries of the JWST could reshape our core ideas about cosmic history, revealing insights not only into distant galaxies and ancient structures but also into the very nature of our own Milky Way. As Mark McFan, Senior Scientist for Science and Exploration at the European Space Agency, puts it, "You build these machines not to confirm theories but to break them. You just have no idea how it will break." The beginnings of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At the time, G. Weir, then head of STSCI, was tasked with envisioning what might come after Hubble. Despite initial doubts, Weir and a small team began laying the groundwork for what would ultimately become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to observe in the infrared spectrum, allowing it to peer much further into the universe. This capability is critical for studying distant galaxies whose light has been stretched into the infrared due to the expansion of the universe, rendering them invisible to telescopes like Hubble. With its large, cold, star-like mirror, the JWST became the primary instrument for uncovering the mysteries of the cosmic dawn. The need for the JWST was highlighted in 1995 when the Hubble Deep Field observation revealed countless galaxies in what was once thought to be a blank patch of sky. This discovery illustrated the richness of the early universe and emphasized the need for a telescope capable of probing much deeper into cosmic history. After years of development and a cost of around $1 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most crucial year of scientific observations. Early initiatives, such as the Early Release Science Program and the General Observing Program, were specifically designed to search for early galaxies. While initial expectations were modest, the results far exceeded them. JWST observations have tested existing models of the early universe, revealing galaxies that challenge conventional cosmological assumptions. These astonishing discoveries highlight the importance of pushing the boundaries of scientific inquiry and showcase the unprecedented capabilities of cutting-edge technologies like the James Webb Space Telescope. As scientists continue to analyze JWST data, they may uncover further insights that challenge and expand our understanding of the universe. When the first data began coming in from the JWST, cosmologists eagerly anticipated the results. Many had been preparing their data analysis pipelines for this moment for years. Rather than following the traditional peer review process, which typically takes months, researchers decided to share their discoveries on preprint servers like AR14, a platform for research papers that have not yet been peer-reviewed. This approach allowed a new kind of peer review to take place through online platforms like Twitter, where established experts could immediately discuss findings. Rohan Natu described this process as science by press release, and the ensuing storm of discussion was both intense and surprising. However, there were concerns about the potential drawbacks of this rapid spread of results. Klaus Pontypool, a JWST project researcher at STSCI, warned that while the quick sharing of results facilitated rapid dissemination and discussion, it also carried the risk of overwhelming the process. The rapid dissemination of findings, particularly in such a groundbreaking mission, posed challenges to traditional scientific processes. The general consensus among most specialists is that the hypothesis of how the universe came to be remains the primary explanation for the early stages of the universe. This hypothesis encompasses the development of stars, planets, and life on those planets, including ourselves. Despite its odd name, the Big Bang, it provides a compelling explanation for what could have happened at the universe's inception. The universe was densely packed into a space smaller than a pinhead, filled with densely packed particles. From this moment, a massive explosion of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set the universe's unfolding history into motion. However, as scientific data progresses, it has raised anomalies that challenge the assumptions of this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, scientists believed that its observations would support the hypothesis of the universe's beginning. Tragically, after just 1 year in space, The telescope astonished scientists with its ability to peer so deeply into the universe's past. The James Webb Space Telescope's extraordinary capabilities have revealed galaxies dating back to a time so ancient that it challenges how we interpret the universe's origins. This revelation has sparked intense examination into what might have existed before the Big Bang.